It's a real pleasure to be here with all of you. The door's closed, so I have a captive audience now. You guys realize this is a philosophy course, right? We're going to do some hardcore thinking, and it's really an honor for me, though, to have a class such as yourselves to think with. I've been studying Whitehead for 10 years, but I wouldn't pretend to understand, everything that he says in his several books. But I feel a great deal of kinship with his way of thinking, and I've gotten to a place where people can ask questions. What would Whitehead think about this or that? And I kind of feel like I know his mind well enough to give a good answer to that type of question. But we also know from Whitehead himself that at the end of his life, he realized that his own, really complex, systematic process philosophy was in some ways incomplete, inadequate. He wasn't happy with the finished product, so he encouraged people like us to continue to tinker with it, to kind of hack the system and see if we can improve the bugs. So hopefully, after I've laid out some of his ideas, you can see what works for you and what doesn't, and maybe we can improve it a little bit. You never know. We're also going to talk a little bit about Schelling this week. Friedrich Wilhelm Joseph von Schelling. He was a German philosopher who died in 1854, and Whitehead was born in 1861, so they almost overlapped. I think of Schelling as a process philosopher before there was such a thing before it was called process philosophy. So we're going to get into his work a little bit first, and then that'll lead us into Whitehead. But today, just by way of introduction, I wanted to sort of set the scene a little bit and talk about the current state of contemporary scientific cosmology. Why is it that Schelling and Whitehead and their alternative understanding of cosmology why do I find it so significant? What does it have to offer to the normal way that scientists approach cosmology? So I think it's important to situate ourselves. I think I don't need to tell you guys who are interested in a school like Schumacher that we're in a bit of an ecological crisis at the moment. And when we engage with these ideas, I don't think of it as just a sort of abstract pursuit that isn't relevant to the way that we live. As Whitehead puts it, as we think, we live. The ideas that we have about the world shape our actions, or at least we hope that they do. There are some understandings of life and the human being which would think of us as more like machines, and where our ideas don't actually matter at all. They're, as T.H. Huxley said, they're just sort of our consciousness, our thinking. It's just the whistle on a train. It's not actually contributing to our actions. Whitehead and Schelling were thinkers who believed that the universe is itself a living organism, and that human beings have a very important role to play as participants, as members of a community of life, and that what makes human beings unique is our self-consciousness and the way that our ideas can transform the world. So what we're doing this week is an attempt to reimagine the human place within the universe and to come to understand how we can be participants here on this planet in a more life-affirming way, and to find a deeper sense of meaning in this 14 billion-year-old energy event that we call the universe. So we're in a geological epoch that many geologists are beginning to call the Anthropocene. Have you heard this term before? Mm-hmm. The idea is that human beings are now a geological force. We're affecting the planet at every level, geological, chemical, the atmosphere. We've initiated a mass extinction, the sixth great mass extinction on this planet, the first one in 65 million years. And it seems to me that part of the cause of this mass extinction, part of the reason for climate change, and the whole ecological crisis with its various facets, is that our understanding of life is inadequate, and the technologies that are birthed out of that understanding are destructive. They're not in alignment with, they're not in congruence with the life systems of this planet. So one of my teachers, Thomas Berry, used to say that ecology is really just functional cosmology. So if our understanding of the universe as a whole is congruent with the way that life actually functions, we'd call that ecology. It gives us a sense of orientation from everything from, how we should farm, how we should think of the soil and treat the soil, how we should build, how we should derive our energy. So ecology is just functional cosmology. So I hope that the cosmology that we end this week sort of creating together will find a function in your day-to-day practices. That's the goal anyways. And after I sort of lay out the trajectory of the course, I want to hear, maybe after tea, I want to hear from each of you just a little bit about what it is that you're hoping to learn this week. There's a lot of different directions I could go, but I want to make it as relevant as possible to each of your own interests and passions. I imagine you're all here to try to understand Whitehead better. So we'll do some of that for sure. So in a way, I like to think of the philosophy that I do as philosophy in a time of emergency, right? Emergency in the sense that something wrong is occurring and we need to address it as quickly as possible, but also in the more hopeful sense of emergence. Something is trying to emerge. And if we can align our consciousness with the deeper creativity of this planet and of the universe, then we can participate in that emergence. Crisis also means opportunity. And if there are historians a century from now, if our species survives this evolutionary bottleneck, I think they'll look back at this period, and the important thinkers will be people like Alfred Whitehead, people like E.F. Schumacher probably as well. Because the ideas that Whitehead articulated were probably about a century ahead of their time. When I started my dissertation work in 2010, Whitehead was just beginning to be rediscovered. And in the last decade or so, there's been quite a Whitehead renaissance. When I started doing my research, there weren't that many books that I had to read, but as I went along, all of a sudden I would read one book and then 3 new ones would be published that I needed to read. So it's kind of a nightmare, but it was also very exciting because this is a guy whose thought I found extremely important and relevant, and he's beginning to now be, I don't know if he's being understood. He's very hard to understand, but there are various facets of his work that are finding applications across a number of fields. And we'll talk a bit about that as we move forward this week. So, contemporary scientific cosmology, if you guys you've all got the readings, right? I think I gave a link to a PDF of this book. Contemporary scientific cosmology finds itself in what I call in this book an epicyclic phase of theoretical development, and this notion of an epicycle is coming out of an ancient astronomical perspective that came out of the work of Ptolemy. It was the pre-Copernican model of the solar system, where the Earth was at the center. And in order to explain the strange movements of the planets, Ptolemy developed a system of circles upon circles upon circles, or epicycles, he called them, so that when a planet would go retrograde, that would be described in Ptolemy's model as an extra circle on the circles that go around annually. And so sometimes the circle would appear to go backwards for a moment. It's a very elaborate construction that Ptolemy developed. And every time an observation wouldn't fit with the model, it's okay, we'll just add another epicycle. And most of the astronomers that built upon this model didn't think that it actually worked that way, that the heavens were actually this giant machine with circles upon circles upon circles. This is, pre-Copernicus, pre-scientific revolution. There was an understanding of the universe as something that was created by God. I'm talking about in Europe here, at least, right? And the way that God did it was just so far beyond anything humans could ever hope to understand, that this model of epicycles, this geocentric model of the solar system, it's just the way that humans have devised to kind of predict where the planets would be. It has no relationship to how God actually does it, right? So when I refer to contemporary scientific cosmology as entering an epicyclic phase, what I'm suggesting is that the reigning paradigms or theories, relativity theory, quantum theory, those are the two major ones in physical cosmology. They each explain a great deal of phenomena, right? Relativity theory explains how the very large things work, and quantum theory explains how the very small things work, but they don't fit together. Relativity and quantum theory describe two very different universes. And a lot of the work in contemporary physics right now is trying to figure out how to get them to fit together, looking for a theory of quantum gravity, or string theory is one approach to this. There are many different approaches. You've all probably heard of dark matter and dark energy. These are what I would call epicycles. So dark matter was invented because Einstein's equations don't accurately predict the speed of the rotation of the stars at the edge of galaxies. They're going way too fast for Einstein's theory. They should be moving much slower if Einstein's theory was right. So the way physicists have solved this problem is by inventing a bunch of invisible mass that must be hiding out somewhere in the galaxies that allows this rotation speed to be explained. So that's an epicycle. That's sort of fudging the data, adding in this extra mass. So we're not talking about a little bit of extra mass here. Dark matter is, I think, supposed to be 28% of the mass in the universe. And then there's this other fudge, this other epicycle, dark energy, which is supposed to explain why, given the strength of gravity that we can measure and understand pretty well, why is the universe expanding at an increasing rate? Where's the energy coming from to do that? Well, we can't see it, but it's expanding, and according to Einstein's equations, the only way to do that is to add a bunch of extra energy or mass. 68% of the mass in the universe is supposed to be dark, coming from dark energy. So that leaves about 4 or 5% left of the kind of matter that we think we understand pretty well. So 96% of the universe is now explained with these epicycles, with these sort of a fudge factor in the equations, in Einstein's equations. And it's kind of funny. The physicists don't think it's funny at all. And I don't mean to downplay the tremendous work that physicists are doing. It's absolutely astonishing, the type of ideas that they are able to come up with to explain the workings of the universe. And Einstein's a complete genius. He didn't believe that the universe was expanding. He actually, his original equation for the general theory of relativity had this part of it called the cosmological constant, which when he first developed it, it did suggest that the universe was expanding. And he said, oh no, that can't be right. So he actually fudged his own equation to get it to be a steady state universe. And then the observation of an expanding universe came in, and he was like, oh, I guess I was right the first time. And quantum theory is, what to say about it? It's using these reductionistic methods that came out of, the work of Descartes and Galileo and Newton originally, after a few centuries of really pushing that reductionistic method as far as it could possibly go. Scientists discovered a universe which wasn't at all what they expected. It turned out that, particles were more like waves, and that they couldn't be separated from one another in space and time, that they could be entangled. The universe began to look more like a giant thought, as I believe it was Sir Arthur Eddington who said that the universe turns out to seem more like a giant thought than a giant machine when you take in the discoveries of quantum physics.
A giant what?
Thought.
I thought.
A thought. Mm-hmm. Like a mind, you could say. So, relativity theory and quantum theory in the early 20th century, they kind of broke the old clockwork model of the universe. And for the last century or so, physicists have been trying to kind of use all their limbs to hold the gears of this clock together. And it's becoming more and more obvious that we're on the verge, I would argue, we're on the verge of a paradigm shift that will be as dramatic as Copernicus' shift to a heliocentric model of the universe, or as dramatic as the Darwinian revolution, where all of a sudden, evolutionary theory changed everything, our understanding of life on this planet. So I don't pretend to know what that new paradigm will look like, but that's the thing with paradigms, is you can't really see it. It's obvious after the fact, but now we're kind of in this mess. And Schelling and Whitehead help a bit. They fill in some of the pieces of the puzzle, but we're kind of still waiting for that genius to have that spark of insight that allows this new perspective to open up, that fits all the data together in a new way. And maybe it won't be one genius, maybe it'll be a team of physicists, but I think we're on the verge of that. Some people think it might be string theory, but so far string theory remains untestable. It doesn't seem like we can produce particle accelerators large enough and powerful enough to give us access to the scale, very, very tiny scale that string theorists are thinking at with their geometry of vibrating strings. So, the nature of science has shifted quite a bit, where most of physics now is so theoretical that it can't even be tested, which science used to be about experiment and observation, right? So it's gotten so abstract and so far from what we can observe or even imagine. A lot of quantum physicists will say, oh, don't try to picture what's happening at the quantum level. You can't picture it. It's mathematics. So just shut up and calculate. And one of the reasons that I'm so drawn to Whitehead is he gives us a way of bringing back together our understanding of the physical universe and our understanding of human experience, so that the two are no longer so, his term is bifurcated. They're no longer so separate. Because what Whitehead was really worried about is the way that contemporary physicists tend to wield their abstractions like weapons to explain away human experience. Purpose, freedom, creativity, love, everything that we value as human beings from the reductionistic physicist point of view is just epiphenomenal or some kind of extra accident that isn't essential to the nature of the universe. I interviewed the MIT physicist Alan Lightman a couple of months ago. He's also a novelist, so he's an example of a scientist that sort of bridges the two cultures, the humanities and the sciences. And yet he's still very much a materialist, and I asked him about the so-called search for the theory of everything, or the grand unifying theory that would bring together quantum theory and relativity theory. And I asked whether we would need to understand the nature of human consciousness, sort of crack the hard problem of consciousness, so-called. Are you guys familiar with the hard problem of consciousness? It's how does the matter of the brain give rise to something which seems entirely immaterial, namely our interior first-person perspectives on the world. There's not even a good hypothesis for how that might be possible, as far as I know. How do neurons and chemicals become conscious if they weren't already in some way conscious? That's Whitehead's solution to the problem. So I asked Alan Lightman if we would need to solve this hard problem of consciousness before we could come up with the grand unifying theory of physics or the theory of everything. And he said, oh no, we don't need to solve the problem of consciousness. That's sort of, it's not really a problem at all. It's produced somehow by the stuff inside the skull. And we just need a really smart mathematician to figure out an equation that will bring together quantum theory and relativity theory. So as far as physicists are concerned, the theory of everything doesn't need to include consciousness, doesn't need to include life, because as far as mechanistic, reductionistic science is concerned, life is an improbable accident, consciousness is an improbable accident squared, and they don't need to be explained, right? The only thing that needs explaining is, gravity and the strong and weak nuclear forces, or electromagnetism. And it's not that these aren't real forces, and it's not that physics hasn't done amazing work shedding light on how these fundamental forces work. Whitehead was a mathematical physicist before he became a philosopher. He was one of the few physicists who in the early 20th century could actually understand Einstein's new equations and new understanding of light and the curvature of space-time. So he takes physics very seriously. But as I mentioned, he's protesting against this tendency of reductionistic physics to explain away human consciousness, human values. he protested against what he called the bifurcation of nature, where, as Galileo was the first to articulate it, there's the primary characteristics, physical characteristics like mass, the length, width, and height of an object. And then there are secondary characteristics, which are everything that perceiving organisms add to it, like colors, sounds, tastes, the emotional quality evoked by the object. All this is secondary. What's primary is motion, mass, the dimensionality of the thing. And that split nature in two, and obviously the secondary characteristics were thought of as just unessential to the real goings-on at the level of the primary physical characteristics. And for Whitehead, this was a huge mistake. And his whole approach to rethinking physics, rethinking cosmology, is an attempt to bring those two back together again, so that his example is the wavelengths of electromagnetic radiation emitted by the sun would somehow cohere with the beauty of the sunset, so that the two could be understood as aspects of the same event, rather than having to say, like most physicists would say, that, well, really it's just wavelengths of light vibrating in space, and color is just something that our organism invents, an inessential extra that we perceive, but that has no importance in the operations of the universe. For Whitehead, beauty, that experience of a beautiful sunset, that's the whole point of the universe, is for organisms to be able to experience beauty. Quite different from your average physicist. So in my conversation with Alan Lightman, he admitted that there were two remaining mysteries for contemporary cosmology to try to solve. One was the origin of the universe. Where did this all come from? How did something come from nothing? And the other mystery was consciousness. And I got into a bit of a interesting conversation with him about the difference between a problem and a mystery, where a problem can be solved with a clear answer, whereas a mystery is not so much a problem that can be solved, it's more of sort of a paradox to be experienced. If there's a solution to a mystery, it's found in a kind of non-verbal, mystical apprehension of just the nature of the mystery. And I kind of see these two, the origins of the universe and the nature of consciousness, unlike Alan Lightman and many physicists, I see them as intimately related, as does Whitehead and Schelling, as we'll see. But I also see them more as mysteries than as problems. I find it hard to believe that entities such as ourselves that emerged in the course of the evolutionary history of this universe could somehow step outside of that universe so as to understand how it could all be possible. If we're going to understand the conditions that make this universe possible, I imagine it to be more of a spiritual experience than some kind of equation or some kind of explanation, right? So Whitehead is not so much after explanations. He thinks the role of philosophy is to elucidate our experience. In his kind of Victorian way, he said that the role of philosophy is to rationalize the ineffable, or to try to bring some understanding to these deep emotional experiences of, mysticism. I think rationalization has different connotations in our sort of post-Freudian, more spiritual kind of New Age culture. We think rationality or rationalization isn't necessarily what we're going for, but I think Whitehead just meant, to deepen our understanding of what's going on. And poetry can deepen our understanding just as well as physics can. So one of the reasons that the origin of the universe remains a problem in contemporary physics is that this problem of what they call the fine-tuning of the fundamental constants of the universe. This is everything from the strength of gravity to other. These are all measured intensities. So gravity is something we can measure. There's something called the fine structure gradient. The speed of light is another constant. I think there are like 45 or so constants. And these are measured intensities that then get plugged into the equations that make physics work. And what physicists have found is that if any one of these constants was the slightest hundredth or thousandth of a decimal place off from its measured value, stars couldn't have formed, galaxies couldn't have formed, life wouldn't have been possible. So the universe that we observe appears to be finely tuned so as to not only allow for the emergence of stars and galaxies, these complex structures, but even more complex structures like living cells, living organisms such as ourselves. So in order to explain this amazing coincidence, physicists have to resort to something like the multiverse theory, where the idea is this universe with these finely tuned fundamental constants arrayed just so as to produce life and consciousness. This universe is just one of infinitely many universes that's constantly emerging from the quantum vacuum. So that we happen to be in one of infinitely many universes, finely tuned just so as to lead to us. I mean, there's got to be a few universes like that amidst the infinitely many other universes. So it's an attempt to, again, explain away the fact that we exist. Now, of course, there's no way, even in principle, to observe any of these other universes. So we seem to have strayed quite far from what science was originally imagined to be, right? This synthesis of empiricism and rationalism. It's become more theoretical, more on the rationalist side, where it's all just mathematical equations, and less on the observational side, less on the side of empiricism. And at the end of the day, though he was quite a speculative philosopher, Whitehead was also an empiricist. And he had lots of criticisms of the rationalist approach to understanding the universe. We're going to get more into the history of philosophy a bit in the next couple of days, so that if these terms don't have significance for you yet, they will as we move forward. And so another way of talking about the fine-tuning is to talk about it in terms of what's called the anthropic principle, which there are stronger and weaker versions of this principle. The weaker version would be something like that we human beings exist and can observe a universe. We observe the universe that's capable of producing us, obviously, right? But this is just one universe out of many. So there's nothing spooky about that, right? We couldn't, if there are infinitely many other universes, most of which have nothing interesting going on in them, right? Just probably plasma radiating in random directions, that we live in a universe capable of producing us, and that when we study the universe, we see, wow, it's all finely tuned just so as to produce us. Well, it's kind of like this observer effect that we couldn't live in any other universe but the one that produced us. And it's an interesting coincidence, but again, we're just one of infinitely many universes. And so that's like the weaker version of it. But the stronger version of the anthropic principle is that actually there aren't infinitely many other universes, or if there are, we can't access them. So why are we basing our cosmology on an untestable hypothesis? But that this universe, the only one we know of and can know of, has a certain tendency to complexify, has a certain tendency to move in the direction of living creatures capable of reflecting upon the fact that they exist. And that's what this universe does. And that would be, if it's not obvious already, that would be the sort of cosmology that I've tried to articulate, building on Whitehead and Schelling's ideas. That we are not accidents in the universe, but that human beings are, and all life is what this universe is for. And Whitehead and Schelling were both religious thinkers. They both had tremendous resistance to the way that Christianity had been articulated by Orthodox, by the Catholic Church and by Orthodox Christianity. They had great criticisms of this. But at the end of the day, their cosmologies left room for the divine, for God, and their cosmology also has a theological side. Whitehead was known for about 50 years, mostly because of process theology. A lot of American Protestant theologians took up his work because it seemed like his image of God was more accessible to people than the traditional image of God. And it was only more recently, as I mentioned, that thinkers outside the context of religion and theology began to take up Whitehead's work. But for both Whitehead and Schelling, rather than God being a sort of transcendent creator of the universe, God is bound up with the evolutionary journey of the universe. God's on the inside of everything. And part of this tendency towards greater organization, greater complexity, deepening, intensified experience, that is what Whitehead would describe as the result of a divine lure. The divine is sort of goading on the evolutionary process towards greater complexity. And human beings aren't necessarily the end of that journey. We like to think we're the most advanced species on this planet, but we'll see. Who knows? Maybe just because dolphins don't have thumbs doesn't mean that they're not thinking some grand thoughts in those brains that are about twice the size of ours. So it seems like whatever the lure is, whatever this divine lure is that guides the evolution of the universe, it produces a whole variety of different species, right? And human beings happen to be dominant on the planet right now, but I don't think that's going to last too much longer. Whether we wake up and realize that we need to, for our own sake, scale back and do things a little bit differently, or whether we don't wake up and just end up driving ourselves into extinction. Even if human beings go extinct, that lure, that tendency towards greater complexity and consciousness will continue. And, we're discovering all these other habitable planets around our galaxy. So there's a sense of hope that this cosmological vision gives me, that in the midst of tremendous destruction on this planet at the hands of human beings, even if our adventure in the process of civilization comes to a calamitous end, it's not the end of the urge of the universe to complexify and become conscious elsewhere, or maybe even on this planet 1,000,000 years from now. So that's kind of the state of things now. That's the big picture as I see it in contemporary cosmology. And I think we're going to want to take a tea break in a few minutes here, but before we do that, I just want to lay out the trajectory of the next few days that we'll have together. So tomorrow, we're going to look at Schelling and his nature philosophy. But in order to understand Schelling, we have to put him in his historical context to see what problems he was dealing with and trying to solve. So tomorrow morning, I'll give a sort of brief overview of the birth of modern science, the scientific revolution, looking at Copernicus and Galileo and Descartes and Newton. And then, so Schelling was a German idealist, right? And he's really in this chain of thinkers that started with Immanuel Kant in the late 1700s, and his critique of pure reason, and his attempt to come up with some compromise that would allow our moral and religious understanding of the human soul to hang together with this new Newtonian form of science and its understanding of the natural world. Kant arrived at what I would call a compromise position to hold these two great truths, the truth of the soul and the truth of what he thought was the truth of a mechanistic nature, together. I also refer to it as the Kantian interval. You guys know the petroleum interval? It's something that the transition town people talk about, where for the last 100 years or so, we've had petroleum that has allowed the human population to skyrocket and this tremendous advance in technology, but it's a finite resource. If we're not at peak oil yet, we'll be there soon. And all the advancement that we've had as a result of oil will recede, and we won't be able to continue living at such a advanced level after petroleum goes away, unless we find alternative sources of energy. So that's the petroleum interval. I think of a Kantian interval in an analogous way, that it's a temporary compromise, kind of let us have our religious view of the inner nature of the soul, and at the same time that science is marching along, explaining more and more of the world mechanistically, but it could never last. And by the time you got to Darwin, where we realized that human beings were an animal species that evolved from other animal species, the idea that the soul was some unearthly substance created by a transcendent God just didn't make any sense anymore. So the Kantian compromise could not continue after that point. So in order to understand Schelling, we have to understand Kant, because Schelling was a student of Kant's, and really, in the simplest way of putting it, is he ends up inverting the Kantian picture. So I have some handy diagrams that will hopefully make Kant and Schelling and some of the other German idealists, including Goethe, who was a major influence on Schelling, and Schelling was a major influence on Goethe as well. We'll see how all of their ideas fit together in order to give birth to this new understanding of the universe as more of an organism than a machine. So that'll be tomorrow. I think we have two, a morning session and an evening session, afternoon session tomorrow, where we'll first in the morning we'll set up the context for Schelling, and then we'll go more into Schelling's philosophy of nature itself in the afternoon session. And then Wednesday, the first session, we'll talk about Whitehead's philosophy of science. So he started as a mathematical physicist, as I mentioned, and in 1920 he gave a series of lectures called The Concept of Nature, where he began to unpack a new philosophy of science, and he thought that this was necessary because of the way that relativity theory, which the special theory of relativity was published in 1905, I believe, and the general theory in 1916, so Einstein's perspective is pretty much brand new, and as I said, Whitehead was one of the few mathematicians who could actually grasp it, and quantum theory was just beginning to take root in 1920, and Whitehead realized that these two new theories totally demolished the old Newtonian picture of the universe. And so he immediately set to work trying to come up with a different philosophical foundation for science. If the old mechanistic picture didn't work, well, we need a new sort of metaphysical underpinning to make sense of what science is telling us about the universe. So he starts developing a philosophy of science first, and he tried to stay out of full-blown metaphysics, but by 1925, when he published Science and the Modern World, he was doing full-blown metaphysics, by which I mean he was coming up with, rather than thinking of particles colliding in space, he developed a new metaphysical scheme that was based on events, interrelated events, the universe as a community of interrelated events, and that these events, from the quantum level on up, were experiential. There's something it's like to be a photon. There's something it's like to be an electron. This is referred to in academic philosophy as panpsychism, or sometimes pan-experientialism, the idea that on some level all is psyche or all is experiential. So Whitehead builds up a new understanding of nature, of the cosmos, on that basis, that what the universe is made of are experiential events. So we'll talk about that on Wednesday. And then on Thursday, I believe we have just a morning session. And we'll try to, and I want some participation on your part to try to imagine what are the spiritual implications of Schelling's and Whitehead's points of view. How do we kind of bring this into our own lives? How do we practice our spirituality in light of the insights of Schelling and Whitehead, which may seem abstract at times, and I apologize for that, but they only seem abstract. They were both trying to be more concrete, actually, about their way of describing our experience. And it seems abstract because they're using new words to do it, because the old words have too much inherited baggage. And so Whitehead invented a lot of words because if he used the old words, we'd get the wrong idea. And so he's really asking us to learn a new language. But once we learn the language, which is a language of process, a language of interrelationship, it's really a more ecological language, then I think I've found, and I think you might find too, that it actually helps us make more sense of what it means to be a conscious organism living in relationship with other conscious organisms. Right? We're not separate particles banging up against one another, which is the way that the mechanistic language would lead us to believe. So what at first appears abstract, I promise you, is actually a more adequate description of who and what we actually are. Tea time?
Sounds good.
Or we could have discussion first, or should we get tea and then come back to discussion?
Let's have a quick 10-minute tea break.
Yeah. Okay.
We can get tea down in the library downstairs. Because we have to finish at 4:20 today, so thank you for a fantastic introduction.
Yeah, that's great. Wow. So we're not touching
Bergson? I'll mention Bergson. Yeah. Mm-hmm.